வெங்கடேஷ் சொல்லுங்க வெங்கடேஷ். அ, very good morning all. We'll start the session so within 5 minutes. Resource person Dr. Venkateshwaran already joined with us, so we'll wait for a few more minutes, then we'll start our session. Thank you. Very good morning to one and all. Kindly wait for a few more minutes. We will start the session soon. Kumadapriya ma'am, shall we start our session? Okay, ma'am, fine. Very good morning to one and all present over here. Myself, Dr. P. Radhakrishnan, Professor and Head ECE Department, Tahor Engineering College. On behalf of management and principal and ECE Department faculty and students, I have a great pleasure to welcome our chief guest, Dr. Venkateshwaran. I feel we are so lucky to have a resource person, Dr. Venkateshwaran. Mrs. Kumadapriya, Associate Professor, is going to introduce our chief guest, Dr. Venkateshwaran. Kumadapriya ma'am, please proceed, ma'am.
Okay, sir. Thank you, sir. Good morning, all. It's my privilege to introduce our today's chief guest, Dr. P.S. Venkateshwaran. Sir has more than 10 years of experience in the domain of additive manufacturing, microfluidics, and nanomaterials. And Sir has completed a doctorate on utilizing SLA and DLP techniques for fabrication of microfluidic devices, which has earned him 3 patents and several high-impact journal publications. And Sir has done his master's on nanotechnology, and he is securing the gold medal at the university level from Anna University main campus. He has done his Bachelor of Electronics and Communication from Tagore Engineering College, affiliated to Anna University. He was technical leading in distributing Mark Bart status and SLM additive manufacturing solution in India. He taught his team of value added resellers across India. He was successful in enabling close to more than 250 customers from the commercial academic space in additive manufacturing. He currently rolled his hexagon involved allying with government and non-government private organization for establishing skill empowerment center across India to upskill and bridge the gap between industry and academia. Yes, sir. I welcome you, sir. Now I am handing the section to Dr. Venkateshwaran.
Dr. Venkateshwaran, please go ahead.
Yeah. Good morning to everybody present here. Very generous introduction, Kumadopriya ma'am, and thank you very much, Radhakrishnan sir, for giving me an opportunity to be able to help the students of Tagore Engineering College. Firstly, I would like to thank our chairperson, Dr. M. Mala ma'am, and our principal, Dr. D. Ravindran, for selecting a person like me to represent the entire batch in terms of an alumni to help these students understand the importance of EC and the opportunity that is available in terms of a huge plethora in the market. And so today's presentations, basically, I'm focusing on the trends that is currently happening, the market situation in India in terms of electronics, and most importantly, the opportunities that is available in terms of, say, job roles, in terms of organizations, and in terms of further studies as well as research. A few domains that I would be covering, because that would be a separate presentation altogether. And at the fag end of the presentation, I've got, since I'm a master, I have these Kuti stories with me. So I would be sharing about 4 or 5 Kuti stories about my students who took up the same domain, and what they were before and what they are today is basically also a critical juncture for you guys to understand as to what you can achieve in your life, despite as to where you are today, or say right now. So, not wasting much of my time. Just to begin with, I'm a proud alumni of Tagore Engineering College, and the professors that you're seeing on your screen today are the reason behind what I am today. So, kudos and a thanks to them. And quickly moving ahead, in today's session, the major outline, as I shared, I would be talking about the current market status in India, because I've been working with several government as well as private institutions in this domain, and would be sharing a few significant opportunities, some of the latest trends, talk about the biggest, policy that our current government has announced in terms of the consumer and industrial electronics. And moving ahead, I'll be showing you a few government names as well as private players in this market. Majority of them would be our customers, and would be talking to you about the Ministry of Electronics and Information Technology. Would also be showcasing to you a few of the job roles that you might get as soon as you complete your ECE, as well as a brief overview on the pay scales. I would be taking an example of a case study and showcasing you as to what are the things that as an ECE engineer you would be able to do once you are, say, out of your education stream and into the job market. And most importantly, at the fag end, there are 2 things which becomes very critical. One is the skills that you need to improve on, or I would rather say enhance on, to become as to where you are, or what you want to be in the future. And 5 Kuti stories. So this is something which is critical, because unless and until I give you real life examples of people who have done what they have, you will yourself start to believe in yourself and get motivated. And last but not least, my contact as always. So yeah, so quickly giving you a brief now, the recently launched PLI scheme, that is it's called as a product link scheme. And there's been a huge input in terms of large-scale electronics manufacturing. Now, if you look at certain corridors in Tamil Nadu, in Karnataka, covering areas like Hosur, Sri City in Telangana, Hyderabad, so there are a few critical pockets in India which have seriously gone into electronics manufacturing, and the advent into electric vehicles over the last 1 or 2 years has been a huge input as well. So let us consider this particular factory, Ola factory, which is inside the Tamil Nadu border. So electric vehicles would be another domain which I would touch upon, but not too much in detail. So I mean, if you look at the companies which are big in the international market, could name a few like Samsung, Pegatron, Foxconn, Haier. And in the domestic mobile phone companies in India, you would see Laba, Micromax, Padjet, UTL becoming a very big name nowadays. And if I look at the ancillaries which supply the components to these big mobile manufacturers, that would be Ascent Circuits, there would be Sastra, there would be Newlink. So there are a few electronic component manufacturers which are really famous in providing all the ancillary or sub equipments for all of these mobile phone manufacturing companies. So What happens in this PLI scheme is that every company is approved in terms of land area, in terms of facilities, in terms of manpower from the Indian subcontinent. And what they bring in is basically an FDI, which is called as a foreign direct investment. So if you look at the aim of the government, close to about 11,000 odd crores is what they are expecting from this PLI scheme. So, I mean, if I convert that into real-time numbers, close to 2 to 3 lakh job opportunities are going to get created in the next 5 years. So now this is something which is very unique because, right since the time that I did my education, I'm sure even my professor, Radhakrishnan sir or Kumdapriya ma'am did their education. Even at that point of time, electronics in India was still in a sort of a nascent phase. We didn't have manufacturing units here. We always had R&D establishments. We always had design related stuffs going on. Even the Intel in India in Bangalore had only a design house. All the manufacturing used to happen somewhere else, primarily or majorly in China, the remainder of it in the US. So that's where, in the next 5 years, the way that ECE is going to get its credentials, or it's going to get its name on the map in India is going to be very big. And if I look at one important aspect, the reason that why I said Intel is very critical here is because companies like Intel are very famous in manufacturing of semiconductor chips or IC chips. And the level at which the research is happening here is in terms of photolithography. We are at a scale of 2 nanometers to 4 nanometers right now. So that's the scale at which we are, developing IC chips. And if you look at the current market in India, we are trying to have manufacturing establishments which could develop it at that scale. And the way that the CAGR percentage is expected is close to go to about $50 odd billion in the next 5 years. So it's something which has never gotten that recognition in India. But trust me, from this year onwards, the next 5 years is going to be very critical in terms of the expansion in fabrication facilities or say semiconductor chips manufacturing. Last but not the least, the ever-evolving, the evergreen PCB market. That is something which can never die. I'm sure that majority of you might agree. It's something which has evolved over the generations, over the decades. I mean, initially you used to have a specific substrate upon which you should have your the insulation line or the conducting line or the semiconducting lines drawn over. But nowadays, there's a lot of laminates that are being used, inclusive of glass. I've seen glass PCB chips. I've seen paper PCB chips, whatnot. I mean, so this is a market which is also under expansion in India. And that is something. And then the last but not the least, a very critical domain, which is called as the medical electronics domain. Now, medical electronics, I'm sure that, of late, in the last 2 years, the importance of medicine, healthcare, and its services has gained a lot of importance. And if I take into consideration a few pockets in India, states like Haryana, states like Gujarat, states like Karnataka, Tamil Nadu, we have got specific institutions or say organizations which are manufacturing electronic devices for the medical industry. And that is another market which is booming like anything. We are having new pockets getting established in Maharashtra, another new pocket getting established in Andhra Pradesh and Telangana. So these are certain very critical policy and the current market scenario in India. So now this would be a right time for all of you to start focusing on where, what, and how to do things in your current curriculum so that you could improve on and grab the opportunity that is available. So let's look at some significant opportunities. Now what happens is on the outset, usually the idea of an electronics engineer or an electronics communication engineer is that we always work towards coding. We always work towards thinking about embedded systems. We always work towards thinking about wireless communications. This would be 3 or 4 domains which we usually focus on. But currently in the market or currently in the research world, there are so many micro domains that have developed over the years. It's something that for every aspect of manufacturing, the involvement of an ECE engineer is always there. Now, to give you a right number, in my current organization, 35 to 40% of the people are currently ECE, from the ECE domain. So you can imagine that whether you are in the design phase or in the simulation phase or pre-manufacturing or prototyping phase, or the actual manufacturing or production phase. Post that, testing and quality phase, an EC engineer is required everywhere. So that's the reason why when you talk about design, production, inspection, and maintenance, these are not terms which are related to only mechanical or mechatronics or people who have worked only on CNC machines or in lathe. The imbibement of robotics in all of these individual domains has gained so much of popularity that the importance of electronics and communication is basically lost amongst people. And if you go towards the background of each of these four critical domains, in say a product development cycle or an NPD cycle, we call that as a new product development cycle. The importance of that engineer is very critical, whether it be the design of a product, or whether it be the design of a chip, or whether it be the design of a PCB, design of individual components, production of these components using robotic arms, inspection of these components using metrology equipments, which also involve huge electronic arms for metrology, for inspection, for quality. So I'll go in individual terms for all of these four domains, and in terms of maintenance and repair as well. So, I mean, the usual mindset of an EC engineer is that there are just four domains wherein we focus our energy on. One is communication systems, another one is consumer electronics, the third is systems and components, and the fourth, a very recent trend is on the automotive electronics. Now, my suggestion, have these four as your baseline, but try to build upon them, because the domains that I'm going to show you in the next slide are going to make you realize that, we are not something wherein, our limitation in terms of domains is not there in terms of ECE. So if I talk about the core industries which are there in electronics and communication, there's a huge load. I could name a few which are very important and very famous in the current scenario of things. And just to focus on a few names, UAV and drones. So it's unmanned aerial vehicles and autonomous drones, whether you consider Amazon, whether you consider Flipkart, whether you consider Apollo. We have also had projects from hospitals asking us to develop drones which could travel in, say, the 5 or 7 feet pathway inside a hospital to deliver medicines. So that's the level at which, domains like drones and UAVs have developed. Now, if I take an example of MEMS, so my PhD guy who is at BITS currently, he works on developing microfluidic sensors, which are of the size of this size of your index finger. And you can actually do your PCR test or your RT-PCR of detecting whether you have COVID or not in that sort of size of a device. So he's now made it commercial. And from this year onwards, you might have say devices which you could carry in your pocket to test whether you have any particular ailment or not. And to name two more industries, one is on the renewable energy systems. That is an area which is totally unexplored. And if you look at the recent news articles that have been coming up in terms of offshore wind power, in terms of, I'm not sure how many of you are from deep down south of India. When you cross down Tirunelveli and you go down south towards Kanyakumari, you would see a huge number of wind farms there. So renewable energy is one such domain which has grown a lot and would continue to grow a lot. So that's another core industry which you could focus on. Biomedical is one more industry, as I just shared with you, the medical electronics stream. So about 4 or 5 to name. I don't want to go too much in detail because the major essence of this presentation would then be lost. So just to give you an overall view in terms of the key technologies available in each of say the primary domains of ECE, whether you take analog or radio frequency circuits, or whether you take networking in terms of wireless communication, encryption of data. I mean, I'm sure that computer vision and image processing, majority of you would know, because if I remember right, during my tenure at Tech, we had at least few projects on image processing. So that is something which has gone way forward. I'm sure if you follow Netflix, and you would see a lot of new series coming up on image processing. So, and if you take sustainable energy and power systems, that's something which from this year onwards, because of the FAME 1 and FAME 2 policies by the government, which is on electric vehicles, that would gain a lot of say name as well as fame if you want to be in such a domain which is going to change the facet of India. And last but not the least, the domain in which I did my master's and PhD, nanotechnology. working on nanomaterials, working on semiconductor manufacturing, point of care devices, microfluidic devices, which Kumadopriya ma'am said. So that's another domain which is pretty famous, right, in India as well as abroad. So just to give you a brief overview of the entire trends in terms of the EC domain and the key technologies that are there, which could be a sort of motivational impact in terms of what you could probably do. Now, critically focusing on, as I had shared before, on the consumer and the industrial electronics market. Now, when we look at India from the top to bottom, now let's take an example of Tamil Nadu itself. Let's take an example of Chennai. And in Chennai, as soon as I ask you, where can I get an electronic component? Imagine, say, a router or a TV screen or say a mouse. Where can I get an electronic component which is really cheap in terms of money? An immediate answer comes in as Burma Bazaar or Ritchie Street. So that's something. So now when we think about Ritchie Street, we immediately come of an understanding that whatever electronic component you talk about, whether it be mobile, whether it be TV, whether it be router, whether it be desktops, PCs, anything related to electronics would be available there, and that too at a cost which is really affordable. So the same ideology goes across India, and if you look at the entire subcontinent, the consumer or the industrial electronics market grabs almost the lion's share of the entire electronics industry. So say more than 50% of it. So if you look at consumer electronics, it's close to about 30%. If I take communication and broadcasting equipment, it's about 10%. The industrial automation or the industrial electronics portion grabs about 20% of the market, and the remaining goes into electronic components, a bit of computers, a bit of strategic electronics, which deals with radars and communications and stuff like that. So the major chunk for all of you to look at in terms of the job opportunities or job prospects would be in this segment. So it would either be consumer electronics, which is 30% of the market, or would be electronic components, 20% of it, or the electronic that is employed in the industry, that is the industrial automation sector. So that's in terms of the current status in terms of the electronics industry in India. Now, what I would essentially wanted you guys to understand that when I give you so many, say, a very big chunk of information stating that these are the domains, these are the trends, as a student, I understand that if I'm at your place, I get confused as to, how, so many things are there, but what is that I should focus on? What would be my interest? What can I actually go about doing? So that's the reason why today I've decided to spend the next 15 minutes to help you understand about NPD, or what we call it as new product development. Now, I'm sure majority of you realize what's there in the image right now. It's basically a PS4 controller. For the matter of it, you could consider any controller. The reason behind why I have taken this example today is to help you understand that as an ECE engineer, where all do you actually put your hands on in terms of any product development cycle? Whether it be a presenter, whether it be a mouse, whether it be anything. Any electronic gadget that you see across you. So I've taken this example today, and when I try to split up this entire, this simple controller, which say it's about 5 inches long, 4 inches wide, and about 3 inches thick. So this small controller involves close to about 15 to 20 departments in an organization to develop. And amidst these 20 departments, we have close to about 300 people involved in the, say, from the ideation till the actual end user getting this product in hand. And most importantly, the cycle of events that happen when you try to open up this controller, you will actually go ahead and understand as to where all an ECE engineer can actually play a very critical part. So now going a bit more into the technical aspect of things, the scheme of things, I would want your total attention, because this is something which would give you an idea either to do a project, or either to take a PhD, or either to take up a master's, or take up job in a particular specific domain. Okay. Now, when I split up the entire components of this controller, you would see that right from the start till the bottom, it has got a lot of electronics involved in it. Other than that, there is a lot of material involvement, structural involvement, design capability, thermal management. So let's quickly focus on the terms which is very critical for an ECE engineer. So one would be a touchpad sensor, right? I'm sure majority of you are using your modern day mobile phones, and this is something which is very awesome in terms of the sensor technology, in terms of touchpad sensors. The button PCBs, wherein you press out all these individual buttons so that it triggers out a signal inside the chip, which eventually connects via Bluetooth and triggers it into the base station of the PS4, and that creates an action move in your game. So all of this happens in less than a millisecond. I mean, rather a few tens of microseconds. So that as soon as you press it, you have a reaction on your screen. So all of this communication pathway happens in say a few microseconds. The next would be a vibration motor, loudspeakers, of course. You have a controller PCB, very critical. From the button PCB, you have the communication being sent to your controller PCB. From the controller PCB, then is communicated using your Bluetooth module to the base station. You have the battery, very critical domain. And for anybody who is thinking of doing masters or PhD, this is something which is going to be, a dream domain to be at in the next 10 years. And last but not the least, the light pipe, the LED, which is currently gaining a lot of market attention. So these are positions wherein an EC engineer takes direct impact. And this I'm talking about a simple small 5-inch by 4-inch by 2-inch controller of a gaming device. Now let's go a bit more in detail. Let's go a bit more technical. So let's understand as to what are the sort of failures that these devices undergo. Now, when you have such a device in your hand, majority of the failures that happens in any electronic devices is majorly because of the capacitor. I'm sure that you understand what a capacitor does. It stores charge. And 26% of it is because of the PCB assay, because the PCB is made up of a particular material. As I had shared before, nowadays PCBs even come in glass. So the material of the PCB, the semiconductor that is being used, the solder joints, as simple as that, connectors. So these are certain areas wherein devices like this undergo failing. And if you want to understand what is that is actually failing, making it to fail is because of the temperature. Imagine that you're using the controller for almost say 4 or 5 hours. So it gets heated up. So you have a temperature issue. There is not enough thermal management or cooling happening because there is no liquid cooling. I mean, see, I'm sure you would have understood about new mobile devices coming with liquid cooling, say carbon-based cooling, copper-based cooling. So temperature difference in terms of problems. Cyclic usage, if you use it for 8 hours, 10 hours, 12 hours daily, continuous usage of it would also result in fatigue of the machine. Humidity and moisture, we are living in a place wherein the humidity levels are pretty high. So you have material in that PCB which doesn't like too much of moisture. Contaminants and dust was, I mean, see, if I take you a decade ago, people would say that majority of the electronic failures are because of dust and contaminants. But trust me, that forms just about 5 or 6% of what is actually failing. And 20% is because of vibration and shock. A lot of people fiddle around with these controllers. If you lose a game, they throw out the controllers. So all of that comes into play in vibration shock. Now, let's understand as to how we go about solving this problem. Okay. So very critical 10 or 15 step process that I'm going to show you right now is on design and engineering. Okay, so this is where a true engineer is born. Whether you are from an ECE background, whether you are from a mechanical background or a mechatronics background, or per se in terms of manufacturing or industrial engineering background, this becomes your say bread and butter for the next say 10, 15 years or 20 years where you want to work. Now, the first important part is on the materials modeling or the materials management. You have to understand what sort of materials goes into the system, what is the sort of lead time that it takes, where do you get these materials from, whether these materials are really useful. Okay, the next step is on the design and modeling, which I'm telling you, it's a very big arm. Whether you're an ECE, whether you're a mech engineer, it's not necessary that AutoCAD or say Creo, or I mean, if you take any name any 3D modeling software, this becomes the basis of how you want to feel or look at a device. So design and modeling. The third would be the PCB concept, the size of the PCBs, the individual IC chips that will go on it, individual capacitors that will go on it, the resistors that will go on it. What is the sort of communication pathway that you want to see see do? What's the amount of heat? I mean, the higher the range of processors that you use, the higher amount of heat it would generate. So what's the thermal management that you're doing? Whether it can take up or even small bits of dust and contaminants, can it handle humidity? So that's the next level of it. The next would be structural integrity. I've seen a lot of people handle controllers very badly. Some throw them, some keep them very nicely, some mishandle it. Now everybody's hands are different. So understanding the structural integrity of any component, whether where the stresses happen, where the loads are, at what angle does the load fall in, how much of force that is enacted upon on a single point. So all of these come into the structural integrity part. Next is the motion. I'm sure if majority of you have used controllers, nowadays it comes with vibration sensors on all end. And as soon as you hit an opponent or you shoot an opponent, you get vibrational impact on your hands, which gives you a real-time feel of holding a gun and shooting. So these are motion controls, which you need to understand. So all of these motion controls in terms of utilizing individual sensors at specific locations to give you that vibrational effect. The next would be a frequency analysis, very critical domain in the communication front. And there it could be natural frequency response or say a force frequency response. Imagine that in the motion pad, you're giving too much of a pressure, you would get a higher amount of vibrational input. If you're giving a soft sort of a touch, you would get a lower vibration input. So all of these analysis comes in. The next or the most critical is the non-linear structural analysis. Now, what do I mean by non-linear is basically out of force. If you try to break the controller, if you try to throw the controller, if it hits the wall, what happens when an unimagined amount of load is hit upon a particular point in that controller? So that's sort of say inputs that you put there. Then would be compiling all of this, reviewing it, putting it out into a pattern wherein you could have the first prototype being developed. And after this first prototype, it undergoes manufacturing processes, which involves plastic injection molding. In certain cases, if it's a metal part, it involves MIM, metal injection molding. And then you take it through quality and inspection. It goes under a CT scan. It goes under various amount of infrared scanners, white light scanners, blue light scanners. And then you have your final process qualification. Okay, so now as an ECE engineer, you can look at all of these individual parts as individual job roles. Person who is involved in materials management is very different than a person who's involved in modeling. A person who's involved in modeling doesn't have much to do with the PCB design. A person who does the PCB design does very little in terms of thermal management, because that's a domain which is called a CFD, computational flow dynamics. Person who does the thermal management is got nothing to do with the structural management, because structural involves both the combination of material, model, as well as the actual thickness of the part. Now, with that, you are having a mechanical engineer come in or a mechatronics come in who does the motion sensor aspects of it. Then you have the frequency analysis wherein a communication engineer comes in. Then you have the non-linear structural analysis, which again would be a sort of a mixture, sort of a field. Fatigue analysis, another electronics engineer comes in. Then you have the impact analysis, a mechanical. And then you have the plastic flow, the review and model update, which involves multidisciplinary domains coming in. Quality and inspection, open to all the engineering fields. So now, quickly moving on to manufacturing and production, because I'm sure that I've done with almost half the time of what I've given in terms of presenting. So in terms of manufacturing and production, imagine this same control needs to be manufactured. Now, ECE engineer falls in all of these domains as well. Now, additive manufacturing, one such, when Kumudhapriya ma'am gave you this introduction of mine, you would have seen that, I have done my portion of a PhD using additive manufacturing or 3D printing. So as an ECE engineer, I developed my own hypothesis. I had this entire machine which I developed on my own. I coded it, and then we were able to 3D print miniature devices. So additive manufacturing is one area. Say subtractive manufacturing is another area. Now, when I talk and say manufacturing, it doesn't essentially mean that it is limited to mechanical engineers. So I'm not a mechanical engineer. I'm an ECE engineer. So you have to keep your mind open and understand that all of these machinery also involves electronics in them. Okay. So whether it be it composites, whether it be treatments, whether it be tooling, whether it be computer-aided manufacturing, that involves software coding. There also an ECE engineer plays a part. Whether it be assembly, whether it be robotics, I need not say anything because robotics is a multidisciplinary domain. You have electronics there, you have communication there, you have mechatronics there, you have mechanical engineer playing a part there. So that's the plethora in terms of the manufacturing and production. And last but not the least, quality and validation. Now this is one domain which I'm sure that majority of you would have never considered it as a sort of a domain itself by itself. Now, when you see that small sticker in all the products that you buy, right, QC certified or QC done, that's called as a quality certification tag. And every industry which is developing a product would have a quality and a validation team, would have a quality and a validation department as such. And all of the equipments that is used there is majorly in terms of electronics, whether it be the robotic arm, whether it be the metrology equipment, whether it be the quality inspection equipment, whether it be the thickness measuring equipment, whether it be it homogeneous mixture measurement equipment, whether it be the coplanarity equipment. I mean, name the equipment there, it involves electronics right from the start till the end. So this is one domain wherein, I have found that the number of people who are from the ECE background is immediate. People think that this is more of an instrumentation sort of a role that is required here, or more in terms of an electrical role that is required here. But trust me, ECE plays a very critical point here. And we could do a separate session on this altogether. Now, so right from simulations to the actual product development to the inspection, an ECE engineer can be there everywhere. So that's the overall essence of what I wanted to explain to you in the last about 10 or 15 minutes. Is that, if you take a small gadget like this and you are able to see as to the number of departments, the number of people from our domain who are involved in developing this particular product. This is just one example. You could name several such examples. Just if you look around your house, you will find 10 such examples wherein you might be directly involved. So in terms of the scopes and opportunities, as I had shared earlier, there are several job roles which you could probably look at when you are graduating from Tagore. Basic job roles such as a technician, a service engineer, an electronics engineer, or technical manager, or a network engineer, whether be it in terms of an R&D engineer or an application specialist. So these are, say, the base job roles that you get across the industry, whether be it on the electronics side or whether be it on the communication front. I've had several friends of mine in Cisco. I've had several friends of mine, even, just to name a few, there is a few who are our own seniors who are there in Cisco and in Intel. So see, these are certain job roles which, as an ECE engineer, you would get in the market. And to answer that $1 million question, right, as to what would be the pay scale, sir. So what happens is, when you are looking at this as an engineering background, initially when you get into these roles, your opening package is somewhere close to about 3 to 4 lakhs. And there are some exceptional cases wherein I've seen people get more than 6-7 lakhs as well. But it eventually depends upon which organization that you're applying to, what is the sort of role that you're applying to, whether you have say multitude of experience. Experience doesn't mean only the number of years, but in terms of simulation experience, hands-on experience, project experience, industrial project experience. So I'm going to be sharing as to what, as an ECE student, that you need to do. Okay. So now, so these are some things which, in terms of skills that you need to develop. So that's basically in terms of the opportunities available in the market currently. Whether you take it up in Monster, whether you take it up in Naukri, you visit any website, or you have your entire internal team at TEC helping you to get core jobs. So this is basically the range at which you would enter in. But trust me, once you gain that initial 5 years of experience, now post that 5 years, you could ramp it up like anything. And the ramp up is in such a rate that if you start somewhere at 3-4 lakhs for your first job, in your second job you could land up somewhere close to 8-9, and a 5 years stint post that, you would somewhere land up at 15 to 18 lakhs. So that's the rate at which you could ramp up in terms of education, in terms of experience in this particular sector, in the ECE domain. So just to give you a prelude, our Ministry of Electronics and Information Technology has evolved over the last 5-6 years, and there are several inherent companies, government organizations, which are there in this portfolio. Now, I would be sharing a PDF of this presentation, so you could click on these individual links and try to find out as to what are the opportunities available online. And these are government institutions, so I'm sure that there's a particular pathway by which you need to go through. whether be it CDAC or whether be it CMET or whether be it ERNET or the newly developed microwave engineering, the Samir project, which we call it as microwave electronics engineering and research. So all of this you could individually access to. So this is from the government website per se. In terms of the organizations in the government sector, you name it, whether it be ISRO, DRDO, DAE, BHEL, BEL, NEC, BSNL, CEL. So there are a lot of organizations which are there. But I understand that from a private perspective, this slide would be a more interesting slide for all of you, which consists of the entire plethora of private organizations. All of them have got offices in India. A few of them have got manufacturing units in India. A few of them are indigenously developing everything in India. One example would be MI. One example would be another example would be ABB. Another example would be Philips. A bit in terms of Schneider Electric. I would also name GE here. GE Electric, and all of these companies are indigenously developing all their products in India, and there has been a lot of foreign direct investments in terms of developing manufacturing facilities. So I'm sure that you will know that there's an Apple manufacturing facility in Bangalore. So yeah, so that's a plethora in terms of the private organizations. Now, one important slide, as I had shared earlier, for people who are interested to do further studies and research. So if I give you examples in the electronics domain, there are topics such as nanoelectronics, such as MEMS, microelectrical mechanical systems, ICT systems, which involves information communication technology systems, Internet of Things. It has gained a lot of popularity over the last few years. I'm sure that you would be experiencing it that inside your home as well. You ask Alexa to do a lot of household tasks for you, whether sing a song for you or whether switch off the lights or switch off the motor. So Internet of Things has gained a lot of popularity for doing an MS or for doing a PhD. In terms of communication field, there's very few people who are actually working on it. So it's an open field altogether. So one is ultra wideband technology, another one is cognitive radios and virtual networks, underground communication, device-to-device communication, most importantly in the vehicular, the automotive electronics that I said, inter-vehicular messaging. Imagine that you're going on a highway, there are few cars going upside, a few cars coming down. So, I mean, there would be internal communication between the vehicles as to what speed they're coming in, whether they need to reduce the speed, and you could communicate. I mean, the vehicles would communicate with each other. So that's a domain wherein you could do a PhD on. The MIMO communication, multiple inputs and multiple outputs. So that's another area at a molecular level. So that you don't you use very less power to generate all of these signals. In terms of the multidisciplinary domain, data security and cryptography has gained a lot of attention recently because of these cryptocurrency problems. Smart lighting is one. The radio signals over the fiber technology. So see, what happened was earlier, decrypting a radio signal was very difficult, but nowadays it's become very easy. But then with the fiber optics, you are able to put out a 32-bit or a 64-bit or a 128-bit encryption in your channel. But imagine you have radio on top of it. So you could add another layer of, say, 8-bit or 16-bit encryption on top of the 128-bit that you're sending below. So radio over fiber. A recent trend is on the Cloud RAN, which is the radio access networks. It's cloud-based architecture for controlling all the individual service towers. Imagine Airtel, BSNL, all of them having the same base stations and sharing their entire load. So you are actually reducing the number of base stations being put. You're reducing the number of people getting directly involved. You are reducing the number of amount of radiation that you're generating out of multiple base stations. So you could have multiple base stations, a single base station having a cloud control, and you could have multiple service providers using it. So Cloud RAN is one of the recent updation in this field. Industrial automation, no doubt about it. If you go visit the Ola factory, which is currently manufacturing the electric vehicles, the two-wheelers one, you would see that majority of it is automated. So they are having individual cells as a manufacturing unit. They are having robotic arms. All of these arms communicate to a central tower, and from the central tower, all of the instructions being sent. So, and industrial automation is another field which you could look at in terms of studies and research. We could do a separate session on this, but I would rather keep it on a separate. So I would be spending the last 15 minutes, or say rather 10 minutes, on the skills to improve and the Kuti stories that I have. And we could have an extended session for about 5-10 minutes in terms of question and answers. Okay. So The primary skill as an ECE engineer that I would want you guys to improve on is to develop your computer proficiency. Now, what do I mean by computer proficiency is not MS Word or Excel or say PowerPoint and stuff like that, but simulation software. Unless and until you are able to learn up softwares which are being used in the industry right now, it will be very difficult for you to bridge the gap between what you have learned theoretically inside the college and what is the expectation in the industry as such. So try to grab out opportunities and go online, search for courses on simulation in terms of electronics. I can probably give a few to Professor Radhakrishnan sir and help him understand as to where all these opportunities are available in terms of learning. But trust me, it's a very critical part in a student's life, and it is very important for you to gain knowledge on these softwares as such. The second would be to develop your communication interpersonal skills. I'm sure that your placement coordinator or the placement team at your institution would be working on this very heavily. But personally, I would say that, take up some spoken English classes or talk to people who are in this domain who would give you some skills to, some ideas to how to evolve that. I primarily developed it by reading novels and taking up all the difficult words online and taking the help of my father to understand a few of these intricate things which I used to read during my college days. So reading improves your skill in terms of English language vocabulary as well as and communication. So I'll tell you as to what to do in order to improve your communication as well. Thirdly, develop your practical skills. No matter what you learn in theory in your classroom, try to see that you employ it inside the lab. If your lab doesn't have that particular equipment, take up 5 to 6 students, form a group, buy a small equipment, try to learn through that equipment. If not, persuade your department to get you some access to the industrial equipments that is there. I'm sure that we are several in terms of alumni who are split into different domains, and we could probably help you with that. The next is to understand what is happening currently in the industry. There is no point in keeping your mind closed, stating that whatever you learn in your curriculum, you will directly employ that in your working organization. So try to understand what is happening in the industry. A few policies that I named before in the first 2 slides, the FAME 1, FAME 2, the PLI policy. Go through the policies that the government initiatives and the government initiatives so that you understand where the industry is heading towards, where, it's no harm in understanding what is Industry 4.0. You can be as stupid as possible. And the more inquisitive you are, the more questions that you ask, the more you will learn. And most importantly, try to see that you get yourself certified. Learning softwares is one aspect of it, but getting yourself certified in those softwares would eventually bridge that gap between industry and academia. So when as an industry resource, when I try to look at the CVs of students coming in, I always firstly see that what additional he has done than the bachelor's that he has taken up. So if he has done additional courses, that gives me a first preference. A second preference is to a guy who has done valid certification from top-notch institutions. To name a few, Hexagon is one, MSc is one, ANSYS is one. So there are several simulation software companies wherein you could get certified yourself with. And last but not the least, as I told you, the communication aspect of it, try to take up leadership roles in your organization or in your current institution. Imagine that you're organizing tech fests, take part in tech fests, get yourself involved in a few of these competitions, take a particular competition and say that you will handhold it on the whole. Try to develop your leadership skills and teamwork attributes, because these are some things which are looked upon very, very cynically in the industry. Unless and until you gel with the team, you are a team player. Unless and until you have taken up some critical roles in taking responsibilities in the colleges. Now, these are things which will actually enhance your confidence in terms of communication skills. So that's the 8-point rule in terms of improving your persona as an ECE engineer, so that you could get into jobs which are of the plethora that I talked to you about. Now, quickly, another 5 to 7 minutes on the Kuti stories before I close up. Now, one Kuti story is about this student of mine. Her name is Akshaya, and she is from Chennai. And she came down to me to take up a few courses in the material science and nanotechnology course at UPES when I was there. and she did it there. She was a student who was always studious. So the first example that I showed to you is a student who has been on the top, say 5 or 6 ranks. And see, I have to cover the entire band gap, right? So I'm starting from the start till the last. Okay, so this is a student who's a good example of. She was very much interested in electronics as such, and she wanted to be in the IC chip manufacturing or semiconductor manufacturing. So she took up all my inputs. She prepared for her GATE, then she prepared for her GMAT, then she prepared for her GRE. She wrote IELTS and GRE together. She cleared it up. She got an MS in nanotechnology in Penn, the Penn State University, University of Pennsylvania. She did there. She used to call me every semester to understand what subjects she has to take in order to enter into the semiconductor manufacturing domain. And she was at a place which is famous for IC chip manufacturing. So I guided her properly, and then at the fag end, she got an internship in this particular organization called as Micron. And I told her to select a particular domain wherein she could enter this. And currently, she's an engineer in the AMD processor. I'm sure that you would have heard about this processing chip before. Intel and AMD are competitors. And she works on the left fag corner. If you look at my pointer, she works on developing masks for photolithography. So she's an advanced mask development engineer, and she does it for AMD chips. And so that's one Kuti story of a student from Chennai. And she had a dream to make it big in the US, and she followed the right guidelines, she followed the right pathway, and boom, that's what she's doing right now. Now, a second important example is of a student of mine who did his BTech in electronics and communication. Okay, and he did it at Sastra, and I see he was basically an NSS unit captain there. He was an NCC volunteer there, and then he took up his master's in energy systems. As I told you, right, there are several domains that I said. So from electronics, his interest towards renewable energy was pretty high. So he took energy systems. I taught him three courses during his MTech tenure. And during that time, I could clearly see that his interest towards understanding the electricity generation in India, the way that distributed generation could help. So we both have a paper that we both wrote, Decentralized Distributed Generation, which has got an impact factor of, we published it in an Elsevier journal of an impact factor of 7. And it's currently, it's going to be the cover page in the next year. So we've got several citations because of that paper. So now this is a student who took it to that next level. From electronics, he migrated towards energy systems, worked towards the electrical aspect of it a bit. And then he worked in 3 organizations. One is on Pollinate Energy. He was a fellow there, and he was working towards giving clean energy access to people below poverty line. He also worked as a public relationship intern in Aadhaar, and he was an energy auditor in the PKR group. Under me, he was a research fellow at UPES, and we worked towards developing sensors for biochemical applications. Now that's when his intent or instinct towards the Indian military grew like anything. So since he had already had a background of NSS and NCC, his volunteering capabilities was heavy. But I could never guess that a person from that sort of a background would enter military. So what he did was essentially he wrote up the TGC. He took up the TGC course, and because of his high percentage of marks in the BTech, he was able to enter the SSB pretty easily. So the Service Selection Board. And after SSB, he did his medical and did about a year and a half of training. And he joined the military, the Ministry of Defense, as a lieutenant. And post that, after 2 years, he became a captain. And 4 years post that, this year, he has been posted as a major. And see, that is something. So an ECE engineer going into renewable energy systems and then realizing the importance of, say, patriotism, and then entering into the defense is one another Kuti story which I felt is unique, and a lot of people would have that in you to end up there as well. So that's another Kuti story. Now the third Kuti story from the third is basically of people who are basically the mid and the backbenchers. I usually don't use these words, but see, essentially I was also a backbencher, but then I used to be good at studies as well. So I have my Kuti story at the fag end to help you understand as to what all I did to where I am today. So this is about Manav, and he was basically a an above average student, a 70-75% odd student. And his major interest used to be events, and events, whether be it societies, chapters, whether be it technical talks, whether be it conferences, roundtables, whatever it is. If there is any event that is going to give some technical input to the institution, he used to be a part of it. So the Material Advantage, he was a chairman there. At UA, he was a core member. At SSPC, he was the vice chairman. And if you look at him, he did his minor and major projects under me directly, and because of that, he got an internship at GPPCL, GPPL, and he developed a rocket arm, as you can see there as an example. And from there, he got an interview into Pidilite, where he works in resins and additives right now. And after resins and additives, it was sort of a techno-commercial role that he handled there. And just this year, he shifted to Lonza. Now, Lonza is an organization which works on the field of chemistry. So you can imagine a person from the material science background going into resins and additives, and then entering into, microbial control solutions that he actually provides right now. So that is an example of another student of mine, Manav Makin, who was basically an average student and above average student. Now, last but not the least, this student of mine is basically a revelation that I would like to say here. Now, to be very frank, I wanted to showcase his entire pathway. That's the reason why I've started it from the 12th standard. Now, he was, say, a 69% holder in the 12th, and he didn't have much interest in studies, as always. And he was interested in exhibitions, in debates, in projects. Anything that was practical, he was interested in. Anything theoretical, he used to shy away. He did his bachelor's under me, and he was an average student. And any event that I used to host, whether it be it a technical talk, whether it be it calling in Professor C.N.R. Rao, whether it be it calling in eminent personalities, he used to be there as a first person. So that is something which made me realize that this is a person who likes action more than examination. So that's when he received 2 opportunities as an internship at IIT Bombay, and 2 more. So that's when I guided him properly, and I told him that take up this internship so that it would give you some meaning in your life. You might not know the importance today, but see, at that point of time, he didn't even understand what Magneti really was. And I do remember to have spent about an hour's time explaining to him that you should take up this internship. And out of force of mine, he took up that internship. He attended a few auto expos as well. And through that, he got a nice opportunity in the R&D center at Force Motors. Okay. And trust me, till that point of time, he had a lot of backlogs. He did not complete his graduation. He had so many backlogs. He was totally stressed up. And at that point of time, he didn't have any motive as to what to do in order to move ahead in your career. So at that point of time, I had called him in, and I told him that, there are a lot of opportunities abroad. So for people who feel that, you haven't done much here, you could take up something which is actually practical. So I gave him an idea about what to do from moving away from a technical domain, going into a management domain. So he got interested. He wrote GMAT, he wrote IELTS, he cleared all his backlogs, all in a single semester. So GMAT cleared, IELTS cleared all his backlogs in a single semester, got a Masters of Management at a French university, and he embarked his journey there. He finished there up, and luckily he got an interview at Ferrari. Now see, luck is one aspect of it, but then when he did that interview, initially he didn't agree to it because the position was offered to him at Singapore and he was in France. But later his profile had gone up top to the CEO, and the CEO looked at his profile and saw these 2 internships that he did, okay, the IIT Bombay and the Magneti Marelli. And the CEO said that I will have a personal conversation with him. And through that personal conversation, he got an offer at Ferrari, Italy, the main headquarters, and he's there currently right now. And that year, he finished up his master's, and he was the valedictorian for the entire batch of masters for all the 4 institutions under that university. So that is something which was really, a privilege for me to watch. It was telecasted live, and I watched it, and it was a really proud moment for me. So a person with that sort of, say, a history, coming up and proving himself and then becoming as to what he is today is something very critical for you guys to learn. I just have 2-3 more minutes left, so let me just quickly grab on and move ahead. So there are about 4-5 learnings out of what he has done. So one would be to not stop believing, always seek and believe that you would be able to achieve something. Keep on asking questions. So these are certain learnings that he shared. Keep on asking questions, whether it be a stupid question, whether it be an intelligent questions. Keep on asking questions. Never try to fail. Okay, so failure is a stepping stone to success. Trust me. I mean, if you look at his career, you would understand that failure has been each of these steps that has helped him climb up to where he is right now. And he always used to say, have a dream job role, never have a dream company. Okay, so never dream of being in a dream company, but have an idea about having a dream job role. So if you like that job role, irrespective of the company, you will enjoy that. You will enjoy working there. And always keep your mind open to learning. As I say, even today, unless and until your mind is open to learning, you would never be able to achieve as to what you have done so far. And just to quickly finish off, giving an example of my Kuti story. I did my bachelor's at ECE, and under the able leadership of Sheila ma'am, who was the HOD that time, and I had Radhakrishnan sir, Kumudappriya ma'am, Anita ma'am. There were 4-5 Lakshmi ma'am, a few of them who had been very instrumental in whatever I've learned in this domain so far. And I had my project published as a paper. I had organized a few tech fests, and I was a student council chairman. I was also the placement coordinator at Tagore. So a huge credit to what I am today goes to TEC. Then I did my Masters of Technology at Anna University main campus. I wrote my GATE and achieved a gold medalist there, and I published several papers. I did my PhD at 2 places. One is at UPES and UQ. At University of Queensland, I started my career, but then I continued it at UPES and did a joint DST project at CSIR and at UPES. And all of the 6 chapters of my PhD thesis are basically published papers. So, and I also received a research award from Professor Sena Rao from the JNU College at Karnataka. So, in terms of my career, I worked at the University of Queensland. Then I worked at UPES. I was a research scientist, senior research scientist. Then I worked at about 5 years at ARK, where I did my, I was an R&D manager. Then I was the national technical manager. And currently I am the technical lead at Hexagon for education and skill development. Now, when you look at this, it feels as if, this person has achieved a lot of things in his life and there has been no hardships. But trust me, and Radhakrishnan sir, I would take 5 more minutes of the time because it's exactly 11 right now. And
no issues. Please go ahead, Dr. Ankit.
Absolutely. So I just wanted to give you a small hint as to what are the sort of individual hardships at every pathway that I went across, so that it would give you something to take forward when you cross the same pathway. So post my 12th, I had completed my, I was the school first there, and I had written the TNPC examinations that time. That time there was no NEET and all. And I had a very big interest in terms of medical, but I lost the cutoff by, say, 0.5 percentile. So I got 98 point something, and I was required to have 98.5 because of being a forward cast. So, and then that's the reason why I didn't focus much on the engineering exam. And in the engineering 11, I scored about 82 or 83 in the TNPC, a combination of 12th as well as my test. So, and I'm very thankful because of that. I entered Tech or Tagore Engineering College, and there I scored about 81%. I wrote IELTS, I wrote GMAT. I had several offers to do my MS abroad, but then there were financial constraints. There were also constraints in terms of what would be my future after that. So what I did was I chose to write GATE, and in that examination of GATE, I scored 97 percentile. And so that was another difficult period because aspiration of becoming a doctor went away. Then I took up engineering, and after taking up engineering, I wanted to do something abroad, but I wasn't able to do it. But then I also got an opportunity to enter into National Institute of Technology, Warangal. Now, I screwed up my own opportunity because the person who was involved in getting me a seat there, he got pissed off because I asked him a question that, what about the Naxalite issues there, and would it impact my education and stuff like that. So he got pissed off, so I lost that opportunity. And then I ended up at Anna University main campus for my MTech. I was the gold medalist there across all the 288 engineering colleges. All that looked green, but the actual help was, after that, I didn't know what to do. because all the companies that came in at Atta University to give jobs were all from the IT firm. Infosys was there, Cisco was there. I had Wipro, I had CTS, I had TCS. Everybody were there, but I wasn't interested. I was interested to pursue more. I was interested to do my research. So at that point of time, I had the help of my director of the Center for Nanoscience and Technology Institute, and Professor Jayvel, and he helped me to take up a fellowship abroad at the University of Queensland, and he guided me, and he helped me to take up that pathway. And being there also, I had a few churning up issues, and then I had to come back home. And I was there at home for about 3 months, which was really painful. I was having a very lucrative offer there, and then coming back to home and being at home was very difficult. And thankfully, because of a small paper cutting that came in the newspaper, which said opportunity for research available at UPES, Dehradun. So that was shared to me by my mother, and I went and attended that, and I got selected, and I developed a lot of labs in that institution. I taught a lot. I mean, the examples of the Kuti stories that you see are all because of the students that I had there. And at that point of time, I had decided to continue my PhD, and then I wrote all of the 6 papers for the PhD entrance in a single shot. There was no friends there. It was a very new place to me. Imagine a person who has been there in Chennai and suddenly goes somewhere north. So that I had to create my own identity there. And then I was promoted. I was given more responsibilities. I wrote joint research projects. But even there, PhD, as people say, would be very a very tricky graduation to do. So there also I faced a challenge. I had to develop my own hypothesis, and the hypothesis which got published had an issue. So we had to change the hypothesis. I had to wait for the papers to get accepted. There was no postdoc opportunities available, and my industry experience was nil. So I had faced a lot of difficulties in terms of completing my PhD. And credits to my wife and my kids who were supportive at that point of time, because of which I was able to complete that. And the next, jump, as you would say, would be at the industry level, which is ARK Info Solutions, wherein I was involved in 3D printing, developing point of care devices. Business management was a critical part there. But moving out from a technical field to an industrial field, there was a lot of challenge in terms of going into a customer-centric approach. There was a lot of importance on sale numbers. There was a lot of travel involved, and an interesting concept of variable pay. So the more you go up in your ladder, in terms of your experience, you would see that in the industry you have a fixed pay and a variable pay coming into the picture. So your variable pay will eventually depend upon the amount of sales that the organization does. So these are certain concepts which you would come up as and when you go across your actual professional pathway. And then on, things changed. I was given a higher responsibility, but then I had my entire team betraying me and exiting at the same point of time. So there was a lot of pressure on me in terms of achievements, in terms of numbers, so people management, and then had a rough patch with my mother's health as well. And currently, where I am right now, I'm dealing with government institutions, government partnerships, and developing a lot of concepts and projects. So these are, it's this year that I've joined here, and a new set of challenges awaits me. So now, when you look at the top half of the picture, it might look really green, but there's a lot of reds at the bottom, wherein you have to, cross a lot of hurdles in order to come to where you are today. So quickly finishing up my talk, since I grabbed an extra 10 minutes. I would just like to put out 3 important quotes by eminent people, which is very critical if you are looking at having a bright pathway for your career. So in a world that is changing quickly, see to that taking risks is very critical, because that is the only strategy that would work. And most importantly, if you are fearing failure, don't be shy of a failure, because failure is the opportunity to begin again. And most importantly, my famous quote, I don't like brooding over circumstances, I create my own opportunities. So, thank you very much to the entire team of Tagore Engineering College for giving me this opportunity. Once again, thanks to Mala ma'am, thanks to Ravindran sir, thanks to Radhakrishnan sir, Kumudappriya ma'am, and the entire ECE team and the students for listening out to me. And that's my contact detail in case you want a sort of a personal input as to where you want to be, what you want to do in your future. You could write down to me. And any official discussion or commitment in terms of professionalism that you want, you could write down to me. Thank you once again for giving me this opportunity, sir.
Thanks, Dr. Venkateshwaran, for your nice and valuable presentation. Students or participants, do you have any queries? Kindly ask your queries.
Yeah, the floor is open to questions now. So I could grab in another 5 or 10 more minutes. Yeah. If you have any questions with respect to your career, if you have any questions with respect to what do you want to do in terms of projects or anything, you could probably ask. Yeah.
Or kindly post your queries.
Yeah, you can even post your queries in the text. If not, my email ID is there, and you can reach out to Radhakrishnan sir as well, and you can personally reach out to me as well.
Dr. Venkateshwaran, I feel very happy. Some of your students got placed in AMD processor, and some of your students placed in defense and Ferrari. All are giant organizations. I hope because of your valuable guidance, they have gone into milestones. I feel personally happy to see all of your students get into a giant organizations. As our resource person suggested, the students of all Tagore Engineering College is advised to do some courses, certification courses, and you have to take some leadership role, and you have to do some internship courses, so that your biodata becomes completely differ from the usual biodata. So as I hope our students might get your suggestions, hope they will soon learn, and they get into a success path soon. Thanks for your valuable guidance. The next, Dr. Porchelvi, Associate, ma'am, Kumudapure, ma'am.
He is pride of Tagu, sir.
Yes, ma'am. He is actually, I proudly say that he is alumni of our Tagore Engineering College. As he conveyed, he has completed B in Tagore in the year 2009. Then, because of his hard work, then he did masters in Anna University. Then he completed his PhD. After completing, he has guided so many students. As just now I conveyed, under his valuable guidance, some of his students get into big organizations. Really, as Kumadapriya ma'am conveyed, he is a very proud alumni of Tagore. Thanks, Dr. Venkateshwaran. Next, Dr. Porchelvi, Senior Assistant Professor, is going to give a vote of thanks. Ma'am Porchelvi, ma'am, kindly proceed with your vote of thanks.
Yes, sir. Thank you, sir. Happy morning to all. On this occasion, I'd like to present my vote of thanks on the behalf of ECE Department, Tagore Engineering College. First and foremost, I'd like to thank our management for the endless support and encouraging us to conduct the webinar. Then I would like to extend my gratitude to our respected principal for his great support. Next, I take this golden opportunity to thank our honorable resource person, our proud ECE alumni, for providing valuable information regarding recent trends and career opportunity in ECE. You have enriched the significant role of our ECE domain in various fields, scope, and job opportunities with some goody stories. It's my pleasure to thank our respected HOD, coordinators, colleagues, and beloved students of ECE department. Last but not least, my closing thanks to the participant from home college and participant from other colleges for spending their valuable time to us. Thank you, sir.
Thank you all. Thanks, Dr. Venkateshwaran. Thank you, Kumadapriya ma'am. Thank you, Porchelvi ma'am. Thanks to all my colleagues and participants from various engineering college, our own organization. Thank you all.
Thank you, sir.
Thank you very much. Thank you, sir. Pleasure.
Yes.
Have a good day. Bye-bye.
Thank you. Now you are allowed to leave from the presentation. Thank you all.
Thank you.
Goodbye.
So Venkateshwaran, sir.
Yes, ma'am.
So my name is Priyanka. I work as assistant professor in Tagore Engineering College.
Yes, ma'am.
And then you see your profile is really very good. The struggles you have taken all over is I can see through. And my brother works for Cisco. He's right now in Cisco Bangalore and networking. And the one thing I have to just to know that starting from the base. That means if completed BE, right? He didn't enter. He completed his ME PG in VLSI design, and he's physical design engineering in Cisco right now. So the thing I want to get to know is like a direct engineering getting into such fields are very difficult in terms. What are all the struggles taken by the students? Because as of right now in engineering colleges, they have the placement for CTS, TCS, Wipro, HCL. Everyone is focusing on to the software, and the package of the software is also about 3.5 lakh students.
That's it. Yeah.
But even though in Chennai we have some companies like they design for RF engineering, and then they have for something for networking, which comes with a very low packages. Low in the sense 2.5, but they'll be given as a design engineers only.
Yes. Yes.
That, but they'll be under some for about the partnership of 2 years of. After that, they'll be having it. Why the students are not entering into such things and they're focusing only on software?
See, there are two aspects to it. One is basically the attraction that these IT companies give in terms of lucrative offices, in terms of the foot joints that they have, the 3.5 lakh package, which is a lakh more than what say an RF engineer might get. But the challenge there is that you are totally shifting out and going into a domain which you haven't had any expertise of. You haven't learned anything there. That is secondly. And thirdly, what happens is when you enter such a domain, what happens is you have to learn everything from scratch.
Yes.
Now the advantage of an EC engineer might be, as I had shared earlier, would be limited in the first 1 or 2 years or 3 years of his career initially.
Yes.
But if once he gains that 5 years of experience, right, he's ramping up. Trust me, the ramping up.
Yeah. The ramping up. I can see people.
It's amazing. I mean,
amazing ramping up.
Yeah, that's the patience that you must have. See, initially your parents would be there to support you, so you should take their help and see to that you have that initial foothold in the industry for about 3-4 years, and then when you step on and go to the next stage, right, you would be way above than anybody who is there in the IT industry. At that point of time, at 4-5 years of experience, nobody enters and gets an 8-9 lakh offer job. See, of course, exceptions are not good examples. There are a lot of exceptions in IITs and NITs and all. But I mean, I usually don't consider them as examples because they are all exceptions. So I mean, if you have to enter that pathway, my critical input that I would give is patience. So patience is the key to success. If you have that foothold, and then you can grab and you can go up very high. And at the same scale at IT, even if you have a 10-year-old experience,
I can
there might be 200,000 odd people who would have the same amount of experience. And
The
you will never
ramping up is
stand out.
the ramping up is only is into electronics that no one is get to know. So even in mechanical industry, even they don't have that much
Surge.
ramping up.
They don't have that surge.
They
Yes,
don't have
that surge is
much
not there.
ramping up.
Correct.
Yes. So your industry sides, like people have to understand how they you're treated right now, when they should get to know what is happening in and around, and then you have to choose
Yeah.
them.
To see now what happens in this sort of presentation is that it stands out as just a sort of a professional presentation. So when I meet these students live, right, what happens is there that question occurs, sir. I mean, you did this, but you faced this, right? So how did you come out? So these sort of questions you will not get in these forums. Now, in these forums, what happens is you stop it at that professional level. So that's where a live one-on-one interaction with all of these students who are looking at developing their career would eventually help. So let's see. I mean, I've spoken to Radha sir. So let's see.
You can build up a break, or we have to make it like what software they have to be learned, and how much patience they have to be given, and how much to be, because I don't want people to enter just into CTS or TCS with the 3.5 lakhs, and settle over there. You mentioned it right. They came, Cisco was available, and you told, see, as of ethics on our side, we have studied UG, PG, and it doesn't like we should not go under fall under their traps for a software engineering work.
Absolutely right. So there's no point in then selecting ECE in your
ECE right now.
Yeah, absolutely. So that there you end up your aspiration totally.
Yeah, I've seen lots of webinars and seminars, but it's like I wanted to get to know all the slides and then go through once again, or again see
Sure.
this
So I
recorded
will
video.
be sharing a PDF version to it of it to Radha sir, and then you can probably grab it from it.
Yeah, sure. Thank you, sir.
Thank you very much. Thank you, everybody. Bye-bye.
Hello.
Sir?
Okay, ma'am. I thought I have finished the presentation.
Sir, Venkatation is not in the line, sir.
ஒரே நிமிஷம். ஹலோ வெங்கடேஷ். சரி சரி, நோ நோ இஷ்யூஸ், நோ இஷ்யூஸ். எனக்கு உங்கள் பேரண்ட் இருக்காங்களா? வீட்டில் இருக்கீங்களா நீங்கள்? பேரண்ட் இருந்தாங்கன்னா கொஞ்சம் கூப்பிடுங்களேன், நாங்கள் பேசணும். டீச்சர்ஸ் வந்து சரி, கொடுங்களேன் கொடுங்களேன், நாங்கள் டீச்சர்ஸ் பேசணும். உங்கள் மிஸ்ஸஸ் இருந்தாலும் நாங்கள் பேசணும். நீங்கள் அம்மாவை ஃபஸ்ட்டு கூப்பிடுங்க. ம். ஆ ஆ மேடம் வணக்கம் மேடம். நாங்கள் வந்து தாகூர் இன்ஜினியரிங் காலேஜ்லேருந்து பேசுகிறோம். உங்கள் சன் வந்து எங்களுக்கு ஒரு வைரம் மேடம். இல்லை இல்லை, உங்களோட ஆசீர்வாதங்கள், உங்களோட இல்லை உங்களோட ஆசீர்வாதங்கள் இன்னைக்கு வைரமாக ஜொலிக்கிறாரு. அதுக்கு வந்து ட்ரூலி ஹீ இஸ் டிசர்வ்டு. அந்த மாதிரி ஒரு நல்ல ஆட்டிடியூடோட, நல்ல பழக்கத்தோட, ஒரு நல்ல மைல் ஸ்டோனுக்கு ரீச் ஆகிறதுக்கு நீங்கள் தான் கொடுத்த பேஸு, உங்களோட வளர்ப்பு. ரொம்ப ரொம்ப சந்தோஷம் மேடம். அந்த மாதிரி ஒரு ஹைட்டில் வந்து இல்லை, அந்த மாதிரி ஒரு ஹைட்டோட போகிறதுக்கு வந்து உங்களோட ஹார்ட் ஒர்க்கு, டெடிக்கேஷனு, அதுக்கு ஹீ இஸ் ட்ரூலி டிசர்வ்டு. எங்களோட குமுதப்பிரியா மேடமும் இருக்காங்க, அவங்களும் பேசணும்னு ஆசைப்படுறாங்க. வெங்கடேஷ் இருக்காரா மேம்? வெங்கடேஷ் இருக்காரா? வெங்கடேஷ் இருந்தா கொடுங்களேன். வெங்கடேஷ், நீங்கள் உள்ளே வாங்கல. குமுதப்பிரியா மேடம் அம்மாட்ட பேசணுன்னாங்க. ஆமாம் ஆமாம், உள்ளே வாங்கலேன். இல்லை இல்லை, இந்த இதில் மீட்லேயே வாங்க. சரி சரி சரி, நோ 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 இஷ்யூஸ். அப்போ குமுதப்பிரியா மேம், மேம் நீங்கள் சரி, ரைட்டு ரைட்டு ரைட்டு, ஓகே ஓகே. தேங்க்யூ தேங்க்யூ.
தேங்க்யூப்பா.
ஆமாம், கரண்ட்டில் இருக்க மீட்டில் தான். சரி சரி சரி, வர சொல்லுங்கள் மேம். குமுதப்பிரியா மேம் கொஞ்ச நேரம் இருங்க மேம்.
ஓகே சார், ஓகே.